Hi everybody, it's Delcy Olds, your friendly neighborhood science specialist, and I just want to talk to you for a few minutes about the new science standards and what we are doing with those as our districts. Okay, so for those of you that don't know, we have new science standards, and this is super exciting news because the direction that these standards are heading really puts us in a good place and is really the direction that we have wanted to go in science. However, we know this involves some changes, so basically this presentation is just to show you exactly how we plan to use our new standards to best help all of our students. So the new standards, here is just a very brief, nitty-gritty, a few facts. There are new standards in 4 content areas, but the big thing is that we have 28 essential standards over 4 content areas. Life science, earth and space science, physical science with an emphasis on physics, and physical science with an emphasis on chemistry. Now, our students are going to be tested on all those essential standards their junior year. One test their junior year. Now, I'm going to talk more about that on the end, so no need to freak out to fast forward because we're going to address that again. Don't worry. If you want to view all of those standards, there's a link right here that's embedded in the PowerPoint that was sent to you as well. Okay. So just a brief touch up on the new standards if you don't know anything about them. The really exciting thing is they've gone from one-dimensional standards, which is just the content. An example of that would be like you need to know everything about the atom. You need to know all the parts of the atom versus you need to use core content, the atom, with a science and engineering practice, something like asking questions, planning and carrying out investigations, engaging in argument from evidence, along with cross-cutting concepts, which are things like looking at patterns, looking at systems and system models, scale, proportion, and quantity, things that we see over and over and over again across a lot of scientific disciplines. So these are also based in research, the framework for K-12 science education and the working with big ideas of science education. These were used to write the NGSS standards as well. But these standards were specifically written by Arizona teachers. So how does this look in Arizona? We have an example right here of an earth and space science standard, which is engage in argument from evidence about the availability of natural resources, occurrence of natural hazards, changes in climate and human activity, and how they influence each other. Now, that's a lot in one standard, so we're kind of going to break down the components here. First, we have the core content, the natural resources, occurrence of natural hazards, and changes in climate and human activity. So that is similar to what we had before in our standards, covering that content. However, you can see it's taught through the lens of a science and engineering practice. So we're not just asking students to know about those different content pieces, we're asking that they do that through the lens of a scientific practice. In this case, engage in argument from evidence. The cross-cutting concepts are not explicitly written into the standards, but you can see here an example of cause and effect, which is one of our cross-cutting concepts. Okay, so again, just to touch on that, of what we just saw, this was an essential standard. We have 28 of those in 4 content areas: life science, earth and space science, physics, and chemistry. They will be tested on all of those standards their junior year. And again, here's the link. Again, I will go over this testing part at the very end of the presentation. So here's our dilemma. How do we get in 4 types of content that have traditionally had their own classes into 3 years of science classes, which is a big task? So the solution was to ask the experts. So we formed a science teacher and leader committee with representatives from all sites and with representatives from each content area. So here we have the group of teachers and teacher leaders who worked on this. It consisted completely of science teachers and of instructional specialists who formerly taught science in their classrooms. So we have a good representation. We have 4 life science teachers, 4 earth and space teachers, 3 physics teachers, and 3 chemistry teachers, as well as representation from each site. You see a slightly smaller representation from Canyon View, but they do only have 3 science teachers this year. Huge props and thanks to this group because they got together and did a ton of work to come up with what we're going to look at next. So Within this day that this committee met, we really wanted to ground ourselves in our AFUHSD district science mission, which is all students are inspired and curious citizens who are using technology, innovation, and 21st century skills to meet high academic standards and solve real-world problems to create a better future. Now, I know that's a whole mouthful, so basically this is what we were looking for. Our challenge was to create a system where every single one of our students receives a rigorous set of scientific courses throughout their high school career. All students have choice in the course sequence that best fits their needs, and all students are equipped with the skills needed to be scientifically literate problem solvers. And with that in mind, that challenge, what we have come up with is a draft of our science essential pathways. So this is probably going to take you a minute. If you want to pause here and download these documents, you have this document right here that you're seeing, which is the course sequence document. And we also have what are like they're not pacing guides, but they have all the standards that are aligned to each course. So what you'll see is principles of science, okay, which essential standards are put into that course, which essential standards are put into environmental science, etc. So if you want to pause that and download that right now, feel free. What you are seeing is a sequence of different ways that students can meet all 28 of those essential standards in 3 years. So if you're wondering how that looks, download that Courses with Essential Standards document. But basically, in every single one of these pathways, students will hit all 28 essential standards. So if a student takes honors principles of science, and then environmental science, and then chemistry, they will hit all 28. If a student takes honors biology, then honors chemistry, then AP physics, they will hit all of their essentials. If a student takes biology, principles of science, and then chemistry, they will hit all 28 essential standards. Now, there will of course be other content and additional standards put into the curriculum for those courses, but the background and what we're talking about right now is just those essentials, because our task was figuring out how do we get all of those essentials into our curriculum for 3 years of science. A couple of frequently asked questions on this. The first one, we've already have students enrolled for next year, so how is this going to change? For example, we do not have a Principles of Science course in our course selection book, and we have students enrolled, so how does that look? We are currently in the process of developing a transition plan for next year where we're not going to change the courses that students are enrolled in, but we are going to look at tweaking and adjusting the curriculum so that they can still have a plan that meets their needs and meets all of the essential standards. Their plan will just be slightly different than the plan you were just presented. How will students be tested in coming years? So next year, it will look just like it has. We will roll out the new standards in our freshman courses, but students who are 9th or 10th graders in biology are still going to take the AIMS. The next year, the same thing. We're going to roll out our new standards to freshman and sophomore courses, but we're still just testing students in biology. In the 2021-2022 school year, that's when we're going to see our new science assessment, which is going to be all juniors tested on those essential standards. So if you want to be involved in writing that new assessment, you can apply here on the Arizona Department of Ed website. They are excited about that. They want a wide representation of teachers and experts from all content, so please apply if you're interested in that. One thing you will notice if you look at this course sequence is that our freshmen next year in the 2021-2020 school year are going to end up taking this test again when they are juniors. They just happen to be our lucky cohort of double tested students. That's true of everyone across the state. Okay, so some next steps. Here's what we need from you. I would love for you to review the draft of the AFUHSD Union High School District course sequences, which is that document that we looked at, and there's another link right here. We also have a 6-month and a 3.5-year plan. Both are to kind of walk through how we're implementing the new science standards and how we're going through this transition. Both are available here if you want to look at those. Provide your input on those standards on the draft of the sequences right here at this survey. And if you have any additional questions or concerns, please reach out to me. I'm happy to talk new standards. I'm excited to talk new standards. And I am always willing to have a conversation with you about those things. So as a district, here's what we're doing moving forward. And you'll see all this if you look in the 6 and 3.5 year plan. But just to summarize that, we're going to use that feedback from your surveys to make any necessary tweaks to the course sequencing document. We're going to create a final draft of the course sequences. And then once we have that, all administrative teams, all counselors, all science teachers will be trained on that new course sequencing. And science teachers will also be trained more extensively on what it looks like to implement these new standards, because these new standards represent more than just a change in sequencing. They really represent a fundamental change in how we look at science education and how we teach that and what our pedagogical practices are. So once we do that, we will also offer training to parents and feeder schools on the new course sequencing so that they're filled in on this. And then we will continue to be responsive to feedback and adjust our plan as needed in order to meet the needs of all of our students. So again, we really wanted this process to be inclusive of all voices and to hear all stakeholder feedback because we really want to meet the needs of students. And so if at any point you want to have a conversation, you have concerns, you have ideas, please reach out. Okay. So this quote from Albert Einstein, "I never teach my pupils, I only provide the conditions in which they can learn." The really exciting thing about these new standards is they really take us from this idea of teaching our pupils and giving them this core content and us as teachers being the vessels of the core content to this idea of we are setting up a classroom in which students are able and conditioned to learn. They are able to dig through things on their own. They're able to develop models and ask questions and develop patterns. They're really able to think like scientists. So while we know that this is a hard transition and there will be bumps along the road, we are so excited for the possibility that implementing these new standards with fidelity will have for our students. So thank you so much. Again, if you have any questions, please reach out to me. I'm happy to talk anytime. Okay.